Turns on. Okay, we are moving on to topic 6. Topic 6 introduces a new idea, a new concept in programming called arrays. It's a very useful concept. By itself, it's not really that difficult, but how it can fundamentally change the way we write programs is the part that is, kind of interesting. So we'll be focusing on arrays from this point onward, and this is your homework assignment called Array 1. So we'll take a look at your homework assignment, and then we'll go back and talk about the assignment itself. Okay? You can see the format is almost exactly the same as the one before because it is still the same thing. I give you a spreadsheet. It has one sheet containing the algorithm, the other sheet containing the a trace. So you have to basically finish the trace in this case. So let's go ahead and download this file to a folder. Okay, so I can just open it in a new folder, and on new tab it saves it. We'll just go ahead and open it. And here is your homework assignment. Okay, some of these things we have seen already, so let me just kind of identify the stuff that we have already seen. Okay, the assignment statement on line 1, no big deal, we've seen it already. While loop, conditional statement, incrementing I, we have seen a lot of that stuff already. What we haven't seen is this notation here, the bar A bar notation. It is not taking the absolute value of something. Okay. It is actually trying to figure out the size or the length of an array. We'll talk about that, okay? So don't worry about it if you don't recognize the syntax of this stuff here. And then we also have, the square brackets in this particular program, which is also something that we'll talk about in this case. And then we have the typical assignment statements, but on both sides of the assignment statement, we can have, something that has a square bracket and something that has a square bracket. So we'll talk about what it is, what it means, and why this type of programming is particularly useful. So that's your homework assignment. And your sheet 2, you start with comments, because we do have a loop and a conditional statements, so you definitely has conditions to evaluate. The value of I is not pre-initialized, because we will initialize it on the first line of this program. T is what we call a temporary variable, so it will be initialized later on in the algorithm as well. The array itself has to be initialized. So in this case, we have an array of 4 elements, 0, 1, 2, and 3, and they do have initialized values, and your program needs to do something about it. Okay. And that's your homework assignment. I will leave this particular spreadsheet open just in case we want to go back and take a look at it. But then, now is a good time to get started with the discussion of arrays. And it has the same problem as the other ones because it just won't show up. Okay, so let me fix that problem first. And by the way, Moodle kind of went down last night. Did you guys notice? I'm not sure whether that's a good thing or a bad thing. It's a good thing that you did not notice. It's a bad thing that you did not notice. Okay, so let's see if that should fix the problem. Yep.
Can you go back to the homework page where you downloaded the file?
Sure. Just hold on 1 second. Let me save this first. Okay.
It says it's due in September.
Oh.
It
Okay.
says it's like 26.
Like overdue for 26 days.
Yeah, we're all overdue now. That's because I copied and pasted. I cloned the other homework assignment. Good catch. Good catch there. Okay, so today is the 26th. I'll give you a week, so it's going to be. It will do on. Wait, hold on a second here.
What's the 22nd?
Today is the 29th of October. So we can do October 29th, and the time is correct. Keep that date and save it. All right. Well, thanks for letting me know because I don't notice these things. All right. Yep.
When do you think you'll have our exams back?
I was about to grade it last night, and then Moodle went down. It was 8:45. It was about 8:20 or so. When someone emailed me and say, well, Moodle is down. I cannot teach my class. I'm going home. So I came back here because I can only reset the server. When I'm on campus. They limit access to the virtual machine console from within campus. So I drove back here, and I got here by about 8:45 or so. But the client software that interacts with the console of the virtual machine is a Windows only kind of thing. So I have to run the virtual machine in my Linux box to run the console software to control another virtual machine. And because I recently updated my QEMU, the hardware has changed, and then Windows decided, hey, I think you're running a pirated version of Windows XP. I need you to re-authenticate and reactivate. So I had to struggle with that for about 2 hours because I didn't have the key with me.
152. Could you use one of the computer labs? Or?
No, the computer lab is already, but those guys are gone by that time.
Right.
So
Yeah,
I came in and when they're just about to leave.
Very speedy excuse.
Yeah.
That's a shame.
Plus, the only my virtual machine has the right, address, the URL to the console, to the server. So I struggled with that for about 2 hours, and then by 10:30 or so, one of my colleagues, gave me a key, so I can actually, reactivate Windows, and I was able to reinstall the software because it wants to be updated. A new version had been released, so that took another 15 minutes or so. Just remember, I'm running a virtual machine on a really old, ancient, gateway computer with only 2 gigs of RAM. So I had to close down everything else, for the virtual machine to run, slowly. And then I tried to authenticate and log into the virtual machine, the remote virtual machine, only to find out that they had, taken my permission away, so I couldn't log in at all. So I was just about to throw my hands up and go, I'm going home and sleep. And then my SSH session just slowly went through. It just actually got through. So I was able to run some commands to find out what's happening on the server. As it turns out, for whatever reason, it's running a lot of processes. Something got stuck, but it couldn't get unstuck, and it's backing up everything else. So it has a load average of 180, which is like really huge. That means 180 processes that are ready to run are waiting for the processor on average. That makes the machine extremely slow. But at the same time, I can at least type commands on the command line interface, and started to shut down some of the unnecessary processes. So without even restarting the server, I can actually resume service on Moodle. So by 1 a.m. or so, because the commands, remember, they were running really slow. So by 1 a.m. or so, I went home because I got everything done here. And then after I went home, I started the backup process because I suspected there was something about the backup process. So I wanted to kind of monitor the process, until up to maybe 2:15 or so. Then I, look at everything. Everything still looks good. So I went to bed at 2:15 a.m. and I woke up at 6:15 a.m. so I can drop off my middle schooler to her 0th period advanced band class. Yeah. But it's a good thing that Moodle is now up, but unfortunately I did not have time to finish my grading. Yeah, things happen, right? All right. So long story short, I'll get it done. I'll try to get it done before Thursday. All right, but getting back to arrays. Okay, so the first thing about array is, why do we need to use arrays? Okay, so this is the usual things that I try to introduce topics, is why. I mean, I can talk about arrays, the syntax, what it is and how to use arrays in your programs, but it's not going to sink in unless you understand, oh, okay, so arrays are useful because blah, 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 blah. Okay, so I'm going to give you some example first, just to understand why we need arrays in order to write algorithms. And I think this is a good time to pass the roll sheet. Hope I have the right one today. Yep, I do. Right, there you go. Start here. Okay, So why do we need arrays? We already have an algorithm to find the maximum of two variables. Okay, you have seen this many times already. It's like, wow, this is not even funny anymore, because we know so much about this algorithm. We proved it is right, it works, we traced it, we have done everything that we can to this algorithm here. It finds the maximum of two variables, in this case x and y, and z becomes the maximum of the two when we are done with this algorithm. Okay, no big deal. We also wrote an algorithm to figure out the maximum of three variables, remember? Okay, so we have, if w is greater than or equal to x, and w is greater than or equal to y, then z gets w, because w is the maximum of w, x, y, and z. Excuse me, w, x, and y. Else if x is greater than or equal to w, and x is greater than or equal to y, then z gets x, because now I just confirmed that x is the maximum of the three. Else, because I only have three variables, the last one, y, has to be the maximum. I'm done. Okay. I understand this is not exactly the optimal way, because the second comparison in the else if line doesn't have to be comparing the two variables. It doesn't need two comparisons, but it doesn't hurt. Okay, this is still a correct algorithm. Can anyone kind of look at this algorithm, the second one, and say, if I give you three variables, okay, if I give you v, w, x, and y, can you generalize and say, oh, okay, I kind of know the pattern. I now know how to figure out the maximum of four variables. Okay, can do that, right? Okay, how about five? Pretty easy. I mean, it's the same approach, right? I mean, you just pick one of the variables, you check to make sure it's greater than or equal to all of the other ones, and then you have just confirmed that it is the maximum. Make sure you update z with that variable, and then you get out of that branch, and you're all done. Okay, what about 30,000 variables?
Lots of if statements.
Yep, you have a pretty long program, but you can do it. The problem is not even that you have a long program when you have 30,000 variables. The problem is, what if you have 30,001 variable? What do you have to do to the program that was able to handle 30,000 variables to begin with? Lots of changes, right? It's not a minor little change. Now, you know the pattern, okay? But just because you know the pattern doesn't make the change any easier, okay? So that's the problem. We are running up against limitations like that. Why do we have to deal with 30,000 variables? What is the enrollment? Okay.
Well, like with this, we're using numbers, even though variables are replacements, and numbers go to infinity. So 30,000 is actually a relatively small number of things to try.
Exactly. But why would I want to deal with 30,000 numbers?
Because you're throwing darts.
You have more than 30,000 end users?
End users or students, okay? If I want to figure out, who has the highest GPA within the district, the entire district has about 80 to 90,000 students, okay? So to figure out the maximum GPA, I will need to, find the maximum of, 90,000 numbers. And I'm not going to find the maximum using this method. It just doesn't make any sense, right? I mean, you can do it, it's just not a very good way of doing it. Okay, so now the question is, how do we do something like this, when we have a huge number of numbers to deal with, and I don't want to write an algorithm that is brittle, which means, if I increase the number of variables just by one, I have to redo the entire thing. It's really cumbersome. So I'm going to give you the algorithm first, just so that you know, how simple the algorithm looks when we use the concept of an array. Okay, so this is the basic algorithm. So we say I is 0. Well, actually, we can make I equals to 1 first, and m is the, okay, we'll keep z as the maximum, and we'll go ahead and do it like this. And we say while I is less than bar a bar. So once again, we have this bar a bar notation. I'll explain that later. I'm just showing you, how the code would look like when we have the concept of an array. So if z is less than a bracket I, then z gets a bracket I. And if I gets I plus 1, and while, and that's it. Okay? So when you look at this algorithm here, I understand that we have notations or syntax that we haven't seen before, but the main point is it's not really that long. I mean, we have 8 lines of code, and yet it can deal with any number of variables. You can throw a million variables at this thing, and it's the same code. The amount of time it takes to execute will be longer as you have more elements to compare, but the algorithm itself is still the same length. Okay, so I think that's a pretty cool concept. Now that I don't have to have a program that is proportional, the length of the program itself is proportional to the number of variables that I have to deal with. Are we kind of doing okay so far in terms of why arrays are useful?
So,
yep.
You used the term riddle on our previous algorithm.
Right.
That's a pretty effective term to label the reason why we have arrays is because we have
I would say so.
riddle algorithms
Yep,
that
because
out there that can really just be shattered by.
Because what is brittle is basically the structure is very stiff, but it's only good for one thing. Okay, the moment you try to make it do something a little bit different, like introducing one more variable and say, okay, I want to include this one when we try to find the maximum, you cannot use the algorithm anymore. So it's now you have to basically break it all up, redo a lot of stuff in order to make the algorithm work. This one is flexible because it doesn't really matter how many variables you throw at it, it's still the same code, which is really cool because now we don't have to say, oh, if you give me 30,000 variables, it's this algorithm. If you give me 60,000 variables, it's still the same algorithm, which is kind of nice. Okay, so the next question is, how can we do something like this? I mean, this seems just kind of magical that we can do something like this. Okay, so to understand that, we have to basically look at how we represent or how we identify variables up to this point. I usually use a coffee mug as an analogy of a variable because the content inside the coffee mug can change as an algorithm executes. Okay, you can put more content into it, you can pour more content out of it, you can empty it, you can fill it up, and so on and so forth. Okay, so right now, before we have arrays, we have individual coffee mugs, and each one has a name. Okay, in this case, we have X, we have Y, we have Z. Okay, in the first example that we were looking at. In this algorithm, we have 3 individual variables, X, Y, and Z, and therefore we have 3 different coffee mugs. Okay, the name on each coffee mug identifies, okay, I want to access variable X, I want to access variable Y, or I want to access variable Z. Are we doing okay so far with this concept? So when you have 30,000 variables, you have 30,000 coffee mugs, and they all need individual names. That reminds me of my pressure cooker at home. It would do the and then it would let out of the pressurized air. Okay. So if you have 30,000 coffee mugs, then you need 30,000 unique names because we need a way to differentiate each variable from the rest in order to access it. And it's not convenient when you need to come up with 30,000 names. Okay? So arrays is a little bit different. An array is actually a box. So now we are talking about a box here. And inside the box, we can put various types of items, like coffee mugs. So in this case, I can put coffee mugs inside a box here. And let's just say that we are also dealing with only 3 coffee mugs. Now the question is, how do I designate the box itself, and how do I designate a particular coffee mug inside the box? The box, being the outermost thing, has its own name. I can call this A, It's just convenient because it's an array. So I call the box itself A. What about the coffee mugs inside the box? Positional, exactly. So we are no longer naming each individual coffee mug as X, Y, and Z. instead, we call these guys by their indexes or just numbers. This is mug number 0, mug number 1, and mug number 2 inside the box A. Okay? It doesn't seem like a big difference. I mean, instead of giving these guys names, I'm just numbering them. Now, the ability to number these guys inside the box instead of naming them is only because they're inside the box already. Now, the name of the box still has to be unique. I cannot have two boxes both called A. I cannot have a box called A and a coffee mug called A. So this A here, the name of the box itself, still has to be unique within the entire program. Well, I take it back. It kind of depends on the programming language, because in some programming languages, you can actually have an array called A and at the same time have an individual variable called A. But we're not going to go there. We'll just say that it has to be unique. Okay. Are we doing okay so far?
Yes.
Now, given this picture, is there a way for me to designate an individual mug like this one here?
Yes.
Yeah, we can say box A and mug number 1, right? You just have to supply both the name of the box and also the number on the coffee mug itself. Okay, so we can call this, coffee mug number 1 in box A. Okay, but in terms of syntax, we just call that A open square bracket 1 close square bracket, which is kind of convenient because if you look at the square bracket, it kind of looks like a box, right? Exactly. So the A is outside of the box because it is the name of the box itself. The 1 is inside the box because it is designating something inside the box. Go ahead.
So it's almost like a coordinate system.
It's kind of like a
Coordinate system.
It is kind of like a coordinate system. For those of you who have taken linear algebra or anything that has to do with vectors, it is kind of like a vector concept. It's also like a coordinate system. You use a number to designate which one you want to use. Okay? Are we still doing okay so far in terms of how to specify a particular coffee mug? Okay? So in this case, A bracket 1, which is corresponding to this particular coffee mug, A bracket 1 can be used wherever you can use a regular variable. In other words, A bracket 1 can appear on the left-hand side of an assignment statement because it's a coffee mug. You can change the level of its content. It can also be used in an expression because you can refer to its content and say, I want to do a multiplication of whatever is inside coffee mug number 1 in box A. Is that making any sense? So when you designate A bracket 1, it is no different from coffee mug X, Y, or Z. It becomes just a coffee mug with a funny name. Okay?
As a label.
As a label, as a way to designate or to identify a particular coffee mug. Okay, so at this point, we're just saying, wow, that's no big deal. I mean, we just have a longer way to specify a particular coffee mug in a program. Well, that's not quite the end of it, okay? Because what this allows us to do is to say A has to be there because it designates the name of the box itself, okay? But the thing is, you can put just about anything within the square brackets as long as it gives you a valid number. As long as this gives you 0, 1, or 2, you can use this to designate one of the coffee mugs inside the box. That is something that we could not do before. So that means I can use a constant, okay? This can be a constant like 1. It can also be referring to a variable like I. It can also be a huge long expression this long, but as long as that expression in the end gives me a value, an integer value that is 0, 1, or 2, I can use that expression. Are we still doing okay so far with that concept? That is why arrays are so powerful, because on the very same line of code, depending on how the expression inside the square bracket is changing its value, each time it can refer to a different item inside the box.
So you can call the same thing something else twice. Is that what we're getting at? We can annotate mug A1 just by giving something within our brackets that's going to derive 1.
Exactly.
So we're able to specify, like let's just say, in a file system, we're able to access the same file, but just in different ways by naming conventions. Is that
It gives you
just
a way.
using that as an analogy?
It gives you a way so that you can calculate which item you want to access inside the box.
Okay.
Instead of being a constant, oh, I want this one or that one, you can say, well, the one that I want to access depends on the outcome of this expression. Okay, that is why arrays are so useful. Now let's go ahead and also talk about the bar A bar notation. The bar A bar notation is kind of like this. How big is the box? How many items are in the box? And that's why it's bar A bar. Okay, because it's just the way that we measure the width of something. Okay, and those notations are fairly unique to this class. The square bracket is universal. Okay, except for Visual Basic and possibly Python. Almost every programming language uses square brackets for array indexing. Okay, array indexing basically is just saying, how do you identify a particular item inside an array is called indexing. All right. Okay, so now that we have covered the basic syntax of an array, are there any questions before we move on and start to use algorithms to illustrate? Yep.
So, looking at the mouse pad that you have there, you're saying that Z will get the value from a mug 0.
Yes, on the second line.
Right.
Yep. So that one is not interesting because this one is no different than saying Z gets X, right? Meaning A bracket 0 is always referring to the first element in an array. Now this is the other thing that I really should have mentioned. The numbering of the coffee mugs always start with 0 in programming languages like C, C++, Java, and just about anything that is derived from C. In Visual Basic, it kind of depends. Sometimes it starts with 0, other times it starts with 1, and in some other programming languages, it can start with any number, which is not relevant to this discussion. So in this class, because it's a prep class for cisp300, we always assume it's starting with 0. All right. Okay. So now that we understand the basic, nomenclature, the naming, the terms of array indexing, let's go ahead and look at some simple algorithms, and then we'll work with some slightly more complicated ones. And as usual, we'll use a spreadsheet to do it, because that's the easiest way to kind of go through a program and also look at how an array is represented. Okay. So we'll go ahead and look at one simple algorithm that will initialize an array. Okay. So in this case, I have I gets 0 while I is less than bar A bar do A bracket I gets, okay, we'll just make it simple. 2 times I gets I plus 1 and while, and this is the program that I'm going to trace at. We'll use a new window and another sheet to look at the trace itself. We have comments because we do have a loop here. We got line number. And we have one variable that is a single one. And then we have A. Now with A, you have to be careful because with an array, in this class at least, and also in general in C programming, most of the time you want to know, how large an array is. In other words, before you run an algorithm that uses an array, at least in the case of C and C++, you really need to know what is the extent or the size of the array before you can get started. So I have to make an assumption here. So I'm going to say, let's say this array has 3 elements. Okay. Now, if A has 3 elements, then it will occupy 3 columns. A bracket 0 goes to column D, A bracket 1 goes to column E, and A bracket 2 will go to column F. It kind of makes sense because each one is a coffee mug. Just like I is a coffee mug, A bracket 0 is a coffee mug, and that's why it needs its own column. Okay, it can hold its own value independent to all of the other variables, independent to variable I, independent to A bracket 1, and a bracket 2. So even all the other elements inside the same array are independent in terms of their values. Are we doing okay so far? So if you look at this picture here, the content of these 3 coffee mugs are completely independent. Okay, they have no relationship with each other whatsoever unless your program, your algorithm establishes a particular pattern. All right. So in this case, I do not need to initialize, or I don't need any pre-value or precondition specified to any of the variables because everything is going to be initialized. This is my precondition. On line 1, I is not a special variable. Okay, so keep in mind that I is really just a regular variable. In this case, it's initialized to 0. And then on line 2, we have to perform the comparison. I is less than bar a bar. So what exactly do you think is bar a bar this time? What is the value of bar a bar?
3.
3, exactly, because we have 3 elements in the array, and therefore bar a bar, which is counting the number of elements in an array, is really just 3. Are we doing okay so far in terms of, bar a bar is 3 in this case?
It's not the sum of 0, 1, and 2.
It is not the sum
It
of the
is the
content, it is
sum
the
of-
number of items in
Yes.
the box. Yep. So you're basically just identifying the number of items in the box. It's just like when you purchase something in bulk, the box will actually tell you the quantity of items in the box, and that's basically bar a bar.
Okay.
So if you have 50 items in that box, you're 50.
Exactly. If there are 50 items in the box, then the bar a bar is going to be 50.
So just how many items you have in the box, right?
Right. It's also known as length of a box. Yep.
Looking at the algorithm and not the trace, how do I see that there's
There are 3 items. You do not. The algorithm by itself does not tell you there are 3 items in the array. So every time you trace an algorithm involving an array, you have to look at the initial trace or the assumption that I give you or the precondition that I give you, because only that can indicate the actual number of elements in the array. Okay. So by the way, each item in an array is officially called an element in an array. Okay.
So if you gave us I gets 5, bar a bar is going to be 5.
Hold on a second. Say again.
If you said on line 1 I gets the value of 5,
Mm-hmm.
we can now make, or we can derive that we have 5.
Nope. Nope.
No?
Nope.
Okay, because I.
The only indicator that there are 3 elements or bar a bar equals to 3 is because I only use columns D, E, and F for array A.
So it's a given.
It's a given in the yeah. Whenever we deal with arrays, we have to know ahead of time how many elements are in the array. Now that is going to be a very important concept going into cisp360, because a lot of the exploits that the hackers rely on in order to break into a system is only because people do not pay attention to that. I'm not sure how many of you have heard of buffer overflow, stack overflow, that sort of thing. Almost every single one of those, buffer overflow, stack overflow, is exploitable only because some programmer did not pay attention to the actual size of an array and attempt, not attempt, I take it back, they do not check the size of an array, and in the code, they would write over the boundary of an array, which can then cause problems. Okay, I'm not going to get too much into the detail of buffer overflow or stack overflow exploits. You have to kind of wait. You have to wait until cisp300 assembly language programming. Then things will actually get a lot more clear how those exploits actually work. Okay, so at this point we are still focusing on I is less than bar a bar, and since bar a bar is 3, I is 0, 0 is less than 3 is true. Okay, so we say true, and then we move on to line number 3. Line number 3 is an assignment statement. The fact that we have an array element on the left-hand side doesn't change the way we deal with an assignment statement. So we still have a right-hand side and a left-hand side. We evaluate the right-hand side, and then we update the left-hand side. So that part has not changed. So we focus on the right-hand side first. The right-hand side is 2 times I I has a value of 0 at this point. So what is 2 times 0?
0.
Okay, so the right-hand side here is just 0. What about the left-hand side? What is the value of I at this point?
0.
I is 0 at this point, okay? So A bracket I is referring to A bracket 0 because I has a value of 0. So A bracket 0 is which column?
D.
D.
Column D, okay? So that's the column that will get a value of 0, okay? Are we doing okay so far with this part here? So the left-hand side of an assignment statement is still the left-hand side, which means it's telling me which column to update. In this case, it is still a column. Column D is just a column, but it is an element inside an array. Okay, so now we move on to line 4. Line 4 adds 1 to I. I goes from 0 to 1. Oops. And then we go back to line 2. I is now 1. Bar A bar doesn't change. It is still 3. 1 is less than 3 is true. We go to line 3 again. And this time we still have to evaluate the right-hand side first on line 3. 2 times I. What is the right-hand side this time?
2.
It's 2 because I now has a value of 2. So that part is not really interesting because hey, we know how to evaluate what is 2 times I. The fun part is the left-hand side, right? Because I is now updated to a value of 1. So when we refer to A bracket I, we are actually referring to A bracket 1. So the same line, which is line 3, in the second iteration of the loop is now referring to a different column. It is no longer referring to column D, instead it's referring to column E. So column E is now getting the value of 2.
This is how they're independent from each other.
Exactly. This is how they're independent of each other. But this is also why arrays are so useful, because by changing the expression inside a square bracket, you can change what that line or what that A bracket something is referring to.
Yeah.
Okay. All right, so this is kind of cool, and we go to line 4. I gets incremented by 1 again to 2. We go back to line 2. 2 itself is less than 3. It's true. We go to line 3 again. And this time on line 3, the right-hand side evaluates to 2 times 2, which is 4. And the left-hand side becomes A bracket I, but I is 2, so it becomes A bracket 2. So now we will store into column F a value of 4. Then we go to line 4 again. I gets incremented from 2 to 3. We go back to line 2. 3 is less than 3 is false. We get out, and we get to post. Does everybody understand how the use of arrays is kind of fundamentally changing, how we can address a particular variable, how we can designate a particular column? Okay, very good. Because understanding why it is important is actually just as important as the syntax, which is just kind of mechanical. All right. Yep, go ahead.
Right here, it seems like you're assigning just +1. What if you were given random numbers?
If you get given random numbers
Yeah.
for I, that's an interesting question. Okay, so let's go ahead and let me first save this program, just in case we want to refer to it again. Create a folder first. Today is the 22nd. Okay, so let me save the program first.
That's simply because of the algorithm on line 4, right? We're just assigning 1 each time.
Say again?
It's a possible way to answer this question, isn't it? Simply because of line 4, we are given add 1 to I each time. That's why we're only incrementing in 1.
Yes. Yeah, remember, I is not a special variable by any means. It is really just like X, that we use in all of our other programs. I is not special. It's really just a variable.
So does this essentially trump everything that we've previously gone over as far as effectiveness?
It's not trumping so much as adding to what we have already used. This class is incremental, which means nothing that we introduce later on will quote unquote trump or invalidate things that we have already talked about. It's just adding to what we have been talking about. So I is not special at all. It's just a regular variable. It's the way we use I on line 3 that makes it very useful, because it is not just a variable that goes from 0, 1, 2, and then 3, and then we get out of the loop, but we also utilize that value inside the square bracket. So that makes line 3 kind of flexible, because depending on which iteration of the loop we are talking about, that line can store a value into a different column. And we did not have anything that even come close to this kind of ability, having the same line to be able to deal with different columns, depending on the value of another variable.
I would be concerned at this point that if I did make an attempt to use an if-then statement, that I could have covered that, or that it may be ineffective in catching everything.
You could do
whereas
that.
I could try to use an array.
But
in the
try,
same scenario.
but try to use an array. Just imagine your array here has 30,000 items. This loop doesn't change. But if you use a conditional statement, so you can switch, depending on the value of I, you switch to different variables, then your program gets pretty lengthy if you have 30,000 variables. Yep.
How would you use that to compare A0, A1, A2? Isn't that where we're heading?
Yeah.
Okay.
Well, but remember, you can A bracket I or A bracket something can appear on the left-hand side. It can also appear on the right-hand side. Nothing says that we cannot refer to the value already stored in an array element as something on the right-hand side, or used in a comparison.
As its location, you're talking about, as far as comparing.
Let's go ahead and
As its contents.
as it refer to its content.
Right.
Because A bracket I is referring to the content of something. So let's go ahead and look at another example. Okay. So the more examples we look at, I think the better chance we have, the more chance we have to understand the concept. So this one will will make it a little bit different by making it this way. So this time I use A bracket. I initialize A bracket 0 to a value of 1, and then I'll say while I is less than, guess what? Or A bar again. But this time I'll say A bracket I gets. Oh, I have to change this one, otherwise it won't work the way I want it. A bracket I minus 1 times 2. Okay. I gets minus 1, and while. Fix the indentation a little bit. Line numbers. And now we can trace it. And just as last time, I'm going to give you an array of, say, 3 elements. Comments, line number, I is by itself, A on the other hand is an array, so we have A bracket 0 taking one column, A bracket 1 taking another column, A bracket 2 taking another column. Go ahead and fix up the width a little bit so they can all fit on the screen. Yes, go ahead.
What determines how many
columns, or how many elements?
Yeah.
It's just, in an example, I would only use 3 in this case, because after the second iteration, it's kind of boring.
Oh, so it kind of determines by itself.
It's determined by the assumption.
What's a practical example of that? Like, whereas you would say, okay, I have.
In reality, the size of
reality.
the size of an array depends on what you're dealing with. For instance, if you're dealing with let's say trying to find out the GPAs of people on this campus, then your array has to be at least about 40,000, because that's the enrollment of this campus. If you're dealing with census data, then you're dealing with the population of the United States. So you're talking about hundreds of millions in that array. If you're talking about, let's say the GPA of all the classes that you're taking this semester, then it may be like up to what, 6 or 7. So it all depends on what you're trying to store in the array, and and there's usually a size limit to it. In actual programming, we use arrays to process, let's say, a TCP/IP, a network packet. Depending on the protocol, it usually tells you, oh, okay, the header portion of this particular transmission can have up to 255 characters. Then you have to allocate 255 elements in that array. So that's how you can, that's how you determine, what would be the appropriate size of an array. But in examples like this, I just use a fairly small number, so it doesn't get too boring. Because if I make this, like 20, it's going to be the repetition. After the second iteration, it's just going to be, oh, okay, we get it, okay? So that's why I pick a fairly small number of elements in the array, for examples like these. Okay. All right, so let's go ahead and start with this one. This one is kind of interesting because on line 4, we have a bracket something on the left-hand side and also on the right-hand side. And then we have I minus 1 inside the square bracket, and then we have a times 2 outside of the square bracket. So we want to figure out, okay, exactly how do we deal with line 4 in this case. Let's start with the easier ones first. Line 1 is easy. I gets initialized to a value of 1, no biggie. Line 2, it's still pretty easy because even though it uses the square bracket notation, what we put inside the square bracket notation in this case is a 0, it's a constant. Okay, it doesn't change. So what do you think, which column am I changing this time to a value of 1? Column D. All right, very good. So a bracket 0 gets a value of 1. On line 3, we have a comparison. I is less than bar a bar. I has a value of 1 at this point. Bar a bar is 3 because we have 3 elements in the array. Is that true or not?
Yeah.
Yeah, it's true. Okay, so we go to line 4, which is the important line. Okay. Okay, on line 4, what we want to do is we want to do this step by step. Okay, so I'm going to switch to, let me see. I'm trying to figure out, how to, okay, I'm going to switch to the mouse pad just so that we can look at this, step by step. Okay, so here's mouse pad, and I'm going to overlay the 2 screens, and I'm going to do something like this. Okay, so the first thing I will do is I'm going to copy the line itself. So this is on line 4. It says a bracket I gets a bracket I minus 1 times 2. Okay. And then the second thing is I'm going to go back to the trace here, and we'll do this step by step. Okay, this is line 4. What do we do first? The very first thing we have to do is what? Sorry, go ahead.
Well, we can subtract I minus 1.
We can perform the subtraction first. Okay, very good. So we know I has a value of what at this point? Has a value of 1. So now we have 1 minus 1, which is 0. Okay, very good. Okay, once we know this is 0, maybe the next thing we can do is to figure out what is a bracket 0, right? What is the value of a bracket 0? 1. It's 1, okay. So a bracket 0 evaluates to 1. And once we know a bracket 0 is 1, maybe we can do the multiplication, right? We have 1 times 2. 1 times 2 is just 2. So the entire right-hand side evaluates to a value of 2. What are we doing with 2? We store it to a bracket I. So once again, we can do it step by step. I, in this case, has a value of 1. So we are actually storing, the left-hand side is specifying a bracket 1. So essentially, we are boiling the whole thing down to just a bracket I gets a value of 2 for this particular iteration. Are we doing okay so far with this?
Yeah.
Okay. So now we go to the column corresponding to a bracket I, which is E, column E, and then we say, oh, okay, we're storing a value of 2 here. It's good. We move on to line 5. Line 5, oops, let me show the algorithm again. Line 5 is just adding 1 to I. I now goes from 1 to 2. We go back to line 3. line 3 is comparing I again. I is 2 this time. 2 is less than bar A bar, which is 3 is true. Then we go to line 4 again. Okay, so this time we'll go back to mousepad and we'll go ahead and re-evaluate line 4 this time. So we have line 4 again. Once again, we'll do it step by step. The most important part is to remember which part to process first. So we'll process, I minus 1 first. I has a value of what at this point? 2. I has a value of 2. 2 minus 1 is 1. Okay, so we evaluate that first. So then the next thing is to do the indexing operation, which is A bracket 1. What is A bracket 1? 2. Has a value of 2. So A bracket 1 is 2. A bracket 1 has a value of 2. Then we have 2 times 2 on the right-hand side, which comes to a product of 4, right? And then on the left-hand side, we have A bracket I, but since we know the value of I is 2 at this point, so the left-hand side essentially is just referring to A bracket 2. So the entire thing, the entire line 4, for this particular iteration boils down to A bracket 2 gets a value of 4. And which column is A bracket 2? Column F. Okay, so column F now gets a value of 4. Then we move on to line 5. Line 5 is just adding 1 to I. I goes from 2 to 3. We go back to line 3. 3 is less than 3 is false. And then we exit the loop. We get the post. We're done. Are we doing okay with this code here?
It seems as though it's exponential.
Yep, it is.
In a sense, and that's how you obtain the effectiveness of an array, correct? Is that kind of a basic summary of what we're looking at here? It's exponential as in it compounds based off of the previous value.
It's just an example,
Right.
to calculate the powers of 2, there are easier ways to do it. But this one is just, giving you an array that becomes, the powers of 2. So A bracket 0 is 2 to the power of 0, A bracket 1 is 2 to the power of 1, and so on. I'm just using it as an illustration.
Maybe I misused the word exponential. Just simply where it compounds based off of a previous number, because we're using substitution based off previous values that we've already derived.
There's no substitution. This is not pre and post. There's no substitution. We are updating a value.
Updating. Okay.
Yep. Go ahead.
I think I missed this the first time around, but how are you doing line 3 again? What is the value of the A in brackets?
Bar A bar, not brackets. Bar A bar is the number of elements in the array. In this case, there are 3. Columns D, E, and F are the elements.
Okay.
Yep. Go ahead.
Could you please go back to the mouse pad so I can see the breakdown of the
Sure.
line 4? Thank you.
Okay, but see, we're given some random value of I, which I don't know where we get, and then all the values after that for A, not A0, A1, A2, they all depend on I. But we were talking earlier about comparing, all the GPAs. They don't depend on each other in any way. So I don't see how
you're finding the maximum, right? So in that case, A bracket whatever is a student's record, and is storing the GPA of a particular student. So let's say I'm trying to compute, who has the highest GPA in this class. So what I would do is I will look at the number of students in this class. I create an array that big. I initialize the entire array so that each element has the GPA of 1 student in the class. Then I can run the find maximum algorithm, and it will find the maximum GPA in this class. No, it's not.
No, you're giving them, you're like, hey, your GPA is 1. Your GPA is 2.
In this case, yes, but not in the previous one.
Seems like that's what
Oh, okay, I see. In the previous one, we're also initializing. Okay, I can give you a third example, for that. In fact, we'll go ahead and run
the key concept for this is that you're able to populate a next item
based on the previous one.
Well, based on the previous one, but also that it's maybe I don't want to say it that way. Let me think about that for a minute. what I wanted to say was you're able to populate a next item without losing or changing the previous item.
Right, referring to the value of
Right.
the previous.
In this case, we just happen to be using math to generate the next item, but that doesn't mean that that's what we'll always be doing.
That's
You
correct.
may be populating the next item with text, and then the next item would be text, and the next item would be text. But it doesn't, it's more the concept of being able to hold them and retain them so that you could make a comparison later, or you could
Because, you know,
use them in some other fashion as well,
because A bracket something.
where
is-
we haven't been able to do that before. We've replaced and said, compare these, and then lose.
Not quite, not quite. When you compare, when you use the comparison operator like less than, you're still referring to the value of whatever expression you specify on this side and the value of whatever you specify on the other side.
Right.
Now, whether this is really just something like variable I or X, or whether this is something like A bracket I, it doesn't matter because A bracket I is still only designating a column, and you're just saying, okay, give me the value of that column so I can compare that to something else. So from that perspective, an element in an array is no different from an individual coffee mug that is not inside the box. Now the difference, the real difference is, for like in this particular program, we can refer to a different item in each iteration based on the value of I. That is an ability that we did not have before. Okay? But once we get to A bracket, blah, 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 close bracket, as long as it is a valid number, it's still just referring to a coffee mug, even though it's inside a box, but you can use it as a regular coffee mug, just as before. Okay? Let me give you another example, okay, another program. Another trace. All right, so this time, we're gonna do something a little bit more fun. We'll say, sorted is, we'll make it true to begin with. And then we'll say I guess 0, while I is less than bar A bar. This time the -1 is outside of the bar. Okay, so we'll try to figure out what that is gonna do. And then we'll say, there are several ways to put this. I'm gonna write it in a cryptic way here. Okay, so we'll say sorted is sorted, and A bracket I is less than or equal to A bracket I plus 1. I gets I plus 1 and while. Okay, so this definitely is something that we haven't quite seen before, but let's see if we can find out exactly how to deal with this based on what we already know in this class. Okay. In fact, what I'll do is I'm going to use some parentheses here just to make it extra clear what we are going to do on that line. All right, even one more. Okay, there we go. Okay. Parentheses never hurt as long as they're at the right place. Okay, there we go. So we have a kind of interesting program here. We have, I would say, two concepts that we have not seen before because we haven't seen the combination before. Yep.
Line 4 where it says sorted and A bracket I, where it says less than or equal to, is that supposed to be gets?
No, it's less than or equal to. It's just less than or equal to. This time it is just less than or equal to. Okay, so we'll go ahead and see what this program is going to do, and here's the trace. So we'll go ahead and take a look at the trace. It's going to take up a little more space this time. So we have comments, we have line number, we have our usual variable I, and the array A. And once again, we'll just have 3 elements in this case because having too many elements is just going to make it boring. But this time I need to have initialized values in the array because otherwise I cannot perform the comparison. So this time I'm gonna have to give you specific values on those lines. Oh, okay, this line needs to be bigger, this one just a tad longer. Okay, there we go. Okay, I starts with an unknown value as our precondition, but A needs to start with some kind of value, okay? In this trace, I'm going to give you one particular case, and then I can make another trace that has a different outcome, okay? So we'll say, let's say this one is not entirely sorted, okay? So we have 2, 3, and 1 here. Okay, there we go. All right, so let's figure out, oh, we have one more variable, don't we? We have sorted as another variable. What? Really? That can be a variable? Well, let's take a
Sorted
look.
gets the value of sorted and.
Exactly, it can store
A
something,
bracket
right?
I.
Okay, so we'll go ahead and start with, sorted is a variable, it starts with an unknown value. Okay, all right, so if I give you a question in exam 2 with arrays, I would typically give you something like this. Okay, the precondition has, at least will indicate the size of an array. In some cases like this one, I would even give you the starting values of elements in the array. Okay, and then we want to figure out, okay, what are we doing here? What will be the value of sorted when the algorithm is done? Okay. Line 1 is an assignment statement. Do we know what to do with an assignment statement? Regardless of what is on the right-hand side and what is on the left-hand side. What is the requirement of the right-hand side? The requirement?
The left-hand side.
Well, it just has to give you a value. Okay? The job of the right-hand side is to specify a value. True is a value, false is a value, 0 is a value. Okay, so there's no problem here. The right-hand side is just a value. In this case, it's a Boolean value instead of a numerical value. But nonetheless, it is still just a value. Okay, it's a value of truth. What about the left-hand side? What is the job of the left-hand side of an assignment statement?
What is being updated?
It tells you where to update, which column to store this particular value. Does sorted have a column? Does it have a column? Yeah, it does. So it is telling me where to store something. What am I storing in column C in this case?
True.
Value of true. Oh, no problem. Right? So look at sorted not as a coffee mug, it's a wine glass. Okay? Instead of coffee or caffeinated drinks, now we have alcoholic beverages. Okay? But nonetheless, it is still a container, and it can still contain a varying degree of content. It can still change as the program runs. Okay, so from that perspective, even though we are mixing and matching concepts that we have never mixed and matched before, it doesn't change the basic meaning of all of those concepts. It's just a different way of combining things. But each one is still doing what it is supposed to do. The assignment statement is still doing the same thing. Evaluate the right-hand side, update the left-hand side. The left-hand side is still doing the same thing, specifying which column we are updating. The right-hand side is still doing the same thing. What is the value that we are storing? So nothing really has changed. Are we doing okay so far? Okay. Now we move on to line 2. Line 2 is just saying while I is less than bar A bar minus 1. But we haven't seen anything like this before. We have seen bar A bar, but we haven't seen bar A bar minus 1.
You said line 2.
Line 2 is.
Oh, line
line
2.
2 is 0. I get 0. Just update.
I got ahead of myself.
Getting excited.
I was like, I'm just.
Okay. I'm too excited
Line
about
three.
line 3.
Line
So we
three.
fast forward to line 3. Okay. So line 3 is I is less than bar A bar minus 1. Hold on a second here. We haven't seen anything like this. Well, we have seen enough. Okay. So we start with this. Okay. We start with just bar A bar. Bar A bar is the number of elements in array A. In this case, how many elements do we have?
3.
3 elements. So bar A bar itself is 3. And we take that value and subtract 1 from it. What is 3 minus 1? 2. Okay. So we can compare 2 to the value in I, which is 0. 0 is less than 2 is true. All right. So Once again, even though we have never seen a combination of bar A bar in the context of a calculation, it's okay because bar A bar is just giving you a numerical value. It's just the number of elements in an array. It's just an integer. You can do whatever you want to do with that integer. You can add to it, subtract from it, multiply, divide, compare, do whatever you want. It's just an integer. Okay. Now we move on to line 4, the really, really nasty line. Okay. So let's see how we can deal with this, really nasty, thing here. Now it doesn't hurt to try to figure out a way to represent an expression that is kind of long and difficult and say, but how do we break this down into, the smallest, components? I'm going to draw this on the whiteboard. So if you want to, mirror this, you might want to use a piece of paper or get your cell phone out and ready to take a snap a picture. Okay. Okay. All right. So what we'll do is we're going to look at line 4, and then we want to figure out how do we structure line 4. Okay. All right. So we have. I'm going to write the whole thing here on the whiteboard first. Sorted gets sorted, and open paren a bracket I is less than or equal to a bracket I plus 1, close bracket, close paren, close paren. Okay. All right, so we look at this nasty thing and say, what is the very last operation that we're going to perform on this line?
Update sorted.
The update. All right. Okay. So the update. So one way to represent this is to use what we call a tree. Okay, but it's a tree that is upside down. So we basically say this is the last operation, but this operation requires 2 things, doesn't it? It requires a left-hand side to tell it where to store. It requires a right-hand side to specify the value. Right? Did I just introduce a new concept?
Yes.
No.
No.
It's the same thing, I'm just recasting it, just drawing it in a different way. Okay, the left-hand side is just, sorted, and the right-hand side is something that would give me a value. Okay. For whatever reason, this, dry board marker is hard to erase, so I'm going to pick a different one. Okay, so if you just focus on the right-hand side, what is the very last operation on the right-hand side itself?
Sorted plus 1, or true plus.
Sorted and.
Just look at the way the parentheses are telling you. What is the last operation? I cannot do that until everything else is done.
Oh, yeah, addition.
The conjunction. The conjunction is the last thing that I can do on that line. Doesn't that make sense?
Yes.
Right? Okay. So this is not working either. And when the trash can was on this side, I would toss it, but since it's this far away, I would kind of hesitate to toss it this far.
Probably gets more than
Or it would bounce and then it would hit somebody.
that. Or leave a mark on the wall.
When I was a kid, my teachers would actually throw chalks around. If I fall asleep in the class, it would go like that, and it leaves a little mark on the forehead. It's just chalk, right? Which is also antacid. Oh yeah, I got a stomach ache that tape. All right, so we have and here, and conjunction requires what? 2 things, right? Okay, it's the conjunction of 2 things. So now we break it up and say, what is one side of this conjunction here?
Sorted.
Sorted. Okay, very good. And what is the other thing that I'm using the conjunction on?
Everything out of
The inner parentheses.
The entire comparison, right? Now, when you look at the comparison, what is the last thing that I have to do with this comparison? I just told you the answer. The comparison itself, right? Because I have to figure out the left-hand side and have to figure out the right-hand side. Then we can actually do the comparison. Okay. So the comparison is the last thing that we have to do. And then you look at the 2 things that we're comparing. What is the left-hand side that we're comparing?
A bracket I.
A bracket I.
Okay, so it's a bracket operation, and I can kind of look at this as an operator itself, because by itself, it also needs to specify which box we're talking about, and then what item we're in, or what item we're accessing in the box. Okay, so I is kind of by itself a something. Okay, and Are we doing okay so far with this one? This one is not a kind of conventional operator, but it is because it still requires two pieces of information.
In theory, you could do it again for I, correct?
Well,
Reduce down
I is
and
by
give it its
itself.
value.
Yeah, I is going to give you a value, so that's kind of the end of it. But the other side is a little bit different because once again we have a square bracket operation. The outside of the box, or the box that we're referring to, is still A, but the inside is not simple. Okay, it's not just I, it is the sum of I and 1. So we have a sum here, or addition here, and then we have I, and then we have 1. So this is one way to break down something like this and then say, oh, okay, so now we know the order of operation because we have to do something first before we can do something, you know, the operation that depends on it. Are we doing okay so far? Okay. So I'm going to use yet another color to indicate values for this particular invocation. Okay. I kind of feel sorry for people who are missing today's class because they cannot really see what's going on here. But it's kind of hard for me to do it on a computer too, because you know that's just going to be wasting a lot of time because I can do this a lot more effectively here. Okay, so at this point I has a value of 0. Okay, so this is 0. So this operation becomes, you know, I want to refer to A bracket 0. A bracket 0 has a value of what? 2. It's a value of 2. Okay, so this entire side is 2. And then over here, I has a value of 0. 0 plus 1 is 1. So the bracket operation is referring to A bracket 1. A bracket 1 has a value of 3. So now we are actually comparing 2 and 3. 2 is less than 3 is true. Okay. What is the value of sorted at this point? True. It is true. What is true and true? Once again, it is true. And now we are storing a value of true into sorted, which is one of the columns, right? So we still have to update it because we are actually updating the value to true again. Okay, so now we move on to line 5. Line 5 is just adding 1 to I. And then we go back to line 2. I is now 1. 1 is less than 2 because A bar is 3. 3 minus 1 is 2. This is still true. Then we go to line 3 again. Oops. Oh, I got the wrong line number. We go back to line 4. So this time, I'm going to erase the pink values because I is now changed. And that's why it is so useful. Because if I change the value of I, the entire expression changes a little bit because I'm changing what columns I'm referring to. So I'm going to erase all the pink portion because a lot of that will change. Okay, so we'll redo this. And we got if I find my pen, I have enough time to do it. Yeah, there you go. Okay, so we start with the same thing here, but I is now 1. What is A bracket 1? A bracket 1 has a value of 3. So A bracket 1 has a value of 3, so it's feeding the 3 into the comparison. I is 1. 1 plus 1 is 2. A bracket 2 has a value of 1. So now we are saying 3 is less than or equal to 1 is false. What is sorted as a variable, as a column? It is true. True and false is false. And then we use false to update sorted. So now we have the column sorted, which is column C, storing a value of false. Yep.
So whereas you mentioned GPA from previous, it's kind of like King of the Hill. You start with any GPA, and then it begins to compare, the array begins to compare or work through the rest of the GPAs, and if it finds one that supersedes or in the comparison negates it, then it's going to update the value of sorted to the highest GPA at that point.
Yep.
There may still be another student a little later on down the line, but it hasn't gotten to it yet. It's just still going through
basically
almost like a horizontal algorithm rather than a vertical.
You're basically trying to store the maximum value because
at all times.
Because the meaning of C in the homework assignment is the largest value that I have seen up to this point. So if the value I have seen up to this point, the largest value I have seen up to this point is actually less than the value that I'm looking at in the array right now, guess what? I just found a larger value, so I better update the largest value to the one that I'm looking at right now. All right. So the lecture is over, and I'm going to upload the notes today. And, okay, Roshi is back. That's good. We need to stop the recorder.
I haven't for this part, so I understand the race pretty well.
What?